Hello everyone and welcome back. My name is Mr. Covalt, and in this video we're going to go over a third example of how to use the method of successive approximations in order to solve an equilibrium problem. And so let's get into this. Okay, so in this particular problem, it's more of a generic reaction rather than the ones we did in the previous examples where you actually had a real reaction. Here we just have a generic reaction, but it works out exactly the same. So you'll see here that we start off with A aqueous plus B solid gives us C aqueous and D aqueous. And we start off with 0.200 molar of the A, and we have 15 grams of the B. And so notice that B is solid, so therefore it will not end up in our expression of our equilibrium constant. So we'll remember that, right? So just remember that solids and liquids do not end up in the equilibrium constant expression. So we look at what we're given, we see, oh look, I have 0 amounts of the product, so that means it's definitely going to shift this way, because at equilibrium we can't have 0 amounts of stuff, especially at aqueous, right? So these are going to be in our expression because they're aqueous. So that tells me that I'm going to lose, since this is all stoichiometrically 1 to 1 to 1 to 1, then all of them are going to be plus or minus x. So there's no coefficient other than 1 to multiply by. So this is going to be a minus 1x or x. We're going to ignore this because it's a solid. That means we're going to gain an x amount of C, and we're going to gain an x amount of D. So when we add those together, we get 0.200 minus x. Here we get just x, and here we get x again. So now we have the equilibrium amounts, the concentrations at equilibrium in terms of x. So now we can write our expression for the equilibrium constant. So in this case, it's going to be KEQ is going to be equal to, remember, it's products over reactants. So the concentration of C raised to its coefficient, which is 1, multiplied by the concentration of D raised to its coefficient, which is again 1. And then that's going to be over the concentration of the reactant A. So reactants are on the bottom. So A, and again, raised to the coefficient of 1. So all of these are raised to the power of 1 because their coefficients are 1. Okay, so now that I have my expression, I can plug in the equilibrium expressions that I arrived at in terms of x. So each C and D is x, so that's going to be x times x all over, and then the concentration of A is 0.200 minus x, so that's going to be 0.200 minus x. So now I have my expression in terms of x. Now, in this case, we have the KE value is, let me write that down, 1.3. So this is going to be equal to 1.3 times 10 to the negative 3. And you can kind of see that 0.200 molar, that's 2 times 10 to the negative 1. That's about 100, a difference by a factor of 100. That's not that's not very different from each other. So these are close. So when your concentrations, your initial concentrations, and your K value, your equilibrium constant, they're relatively close, like by a factor of 100, maybe even 1,000. Your x is negligible assumption is probably not going to work in that case. So it's probably not going to work here, but we're going to do the first iteration of solving for x using that assumption, and then we'll do the 5% rule to show that it doesn't work, and then we can do the successive iterations and to get to the final correct answer for x. Okay, so let's go ahead and assume, okay, well, if x is negligible, then this is effectively going to be 0, right? And then we're going to solve for x here. So then what we have here is x squared over 0.200 is going to be equal to 1.3 times 10 to the negative third. Multiply both sides by 0.200. Multiply this by 0.200. Right, so that's going to cancel out. And then if we multiply those together, let me get my calculator. So if I calculate this, I get 1.3 times 10 to the negative 3 times 0.200 equals, and I get 2 point. So that's going to be equal to, so I have x squared now equal to 2.6 times 10 to the negative 4. And now I just take the square root of both sides and I get x1. My first x is going to be equal to 0.0161. Now, I should have only 2 sig figs, but I'm keeping an extra one for rounding purposes to avoid rounding errors. And so this is the x value that I got. Now, we're going to see if that passes if that passes the 5% rule, meaning that if it's 5%, if it's 5% or greater, then it doesn't pass. If it's less than 5%, then we know that our assumption here that x is negligible is valid. If it's not valid, it's going to be a higher than 5%. So if we do our 5%, that's going to be the concentration, the initial concentration that we started with. This x divided by that. So the change divided by the initial concentration. So 0.0161 divided by the initial concentration, which is 0.200. Multiply that by 100. Right, so it's the change divided by the initial concentration, or what we got for x divided by the initial concentration multiplied by 100, and we'll find that that's about 8%. So we get about 8% error, so that's higher than the 5%, so that means that our assumption here was not valid, but that's okay because now we can continue with the iterations using the successive approximation, which means that all we have to do now is take the x value that we got, plug that in for the x that we ignored, and then calculate x again, right? And see what we get the second time. And what we're doing is we're trying to get an x value repeated twice in a row. So if we get the same x value twice in a row, that means we're done. We've reached our actual value. So here, so I have x, we'll write it over here, x1 is 0.0161. Okay, so now what we're going to do is we're going to plug it in for x. So we're going to plug it in here. So now we have x squared over 0.200 minus 0.0161, and that's going to be equal to 1.3 times 10 to the negative 3. Okay, so we do our calculation here. So that's going to be 0.200 minus 0.0161 equals and that gives us 0.1839. So we get x squared over 0.1839. That's going to be equal to 1.3 times 10 to the negative 3. Okay, so now we multiply both sides by 0.1839. Multiply this side by 0.1839. Right, so then that's going to cancel out. Now we multiply these together. Let's go ahead and do that. So then I multiply that by 1.3 times 10 to the negative third equals, and I get 2.390. So here I get x squared is equal to, oops, let me write that up here so I'm on screen. So we get x squared is equal to, what I get? 2.3907 times 10 to the negative 4. And then I take the square root of both sides. So then I get x, and this will be my second x, x2. That's going to be equal to, let me calculate this. So I get 2.3907 times 10 to the negative 4. And oops, hold on a second. I'm going to take the square root. Square root of 2.3907 times 10 to the negative 4 equals, and I get 0.0154. Okay, so that's my second x value. We'll write that here. So x2 is equal to 0.0154. Again, I'm keeping an extra digit for rounding, to avoid rounding. And so now you'll notice that my x1 and x2 are different. So I have to keep going. So again, I'm looking for two successive x values that are the same. Once I get two successive x values that are the same, I know I can stop, right? So then I got to keep going. So what I'm going to do is I'm going to put this value back into x here and do the calculation again. So let's do it again, and we'll see if we get the same answer. So again, it's going to be x squared over 0.200 minus, and then I got to put in the x value, 0.0154, 0.0154. That's going to be equal to 1.3 times 10 to the negative 3. So I do the calculation here on the bottom. So 0.200 minus 0.0154 equals, and I get x squared over 0.1846, and that's going to be equal to 1.3 times 10 to the negative 3. So now I'm going to multiply both sides by 0.1846. Multiply this by 0.1846. Okay, so I do that calculation. So I'm going to multiply by 1.3 times 10 to the negative 3 equals, and I get x squared, I'll write it over here, x squared is equal to 2.3998 times 10 to the negative 4. right? Okay, 2.3998, yes. So I take the square root of both sides, and let's do that. So now I'm going to take the square roots to square root of 2.3998 times 10 to the negative 4 equals, and I get x3 is equal to 0.0154. And now look, so this third x value I got is the same as the second one, so that means I can stop, and I have now reached the actual value of x. Now, this is not an approximation. This is the exact value that you would have gotten if you would have done the quadratic equation using the quadratic formula, right? So this is a much faster way. Now, it may not seem like a much faster way, but when you get proficient at this and you know how to do it quickly on the calculator, this will be a lot faster than doing the quadratic formula and trying to figure out and solve the quadratic formula, right? So this is a very powerful tool and method that I highly recommend. So it's just going to come with practice. After you do it a few times and you know how to do it on your calculator really quickly, you can do the successive iterations like in a matter of, minute, right? You could probably do them in a minute. This is, again, a powerful tool. So I hope this is helpful. I hope you enjoyed the video, and if you learned a new thing because of my videos, then by all means like the video, share the video, hit that like button somewhere over there. Also, do me a favor, subscribe to my channel, hit that notification bell right up there. When you do that, click all so you can be notified about all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to help you with whatever you need help with. Thanks for joining me, and have a great day.